Hello friends, in this video I will discuss the analysis method of piles as per API RP2A. Here are the design parameters of the piles. The diameter of the pile is 16 inch and its thickness is 1 inch. We have used lifting padeyes to lift the pile. The whole diameter is 46 mm and it has a thickness of 1 inch. I have considered structural steel as material of the pile. It has a yield strength of 250 megapascal. On the right, we can see a pile connected to the lift point using beam connections. The angle of the beam connection is 60° with respect to horizontal axis of the pile, which is generally followed in industry. I have planned this analysis in 4 steps. In the first step, I will carry out the horizontal lift analysis using 2 lift points. In the second step, I will carry out a lift analysis of the pile when it is at 4° with respect to ground. In the third step, I will carry out a vertical lift analysis of the pile, and in the final step, I will carry out the buckling analysis of the pile. Here is a video which shows the installation and utility of pile. This clip is part of a video owned by CV Heavy Lifting, which is located in Netherlands. So first we will define the engineering data. So I have defined the Young's modulus and Poisson's ratio for the structural steel and also the density. Let's go to the mechanical module. I will define a local coordinate system. I have defined a freestanding remote point which will act as the lift point for this lift analysis. The coordinates of this lift point are shown here. I will show you the method of how to extract these coordinates from the analysis. Now I will define the beam connections. I will create a mesh for the file. Now I will define the loads and boundary conditions for this analysis. So I will assess this pile for twice the gravity loads, which is in line with the requirements of API RP2A. In this analysis, large deflection option is turned on to capture the significant deformation in the pile, and the weak spring option is turned on to ensure the stability of the calculation. Let's run the simulation. Let's check the results. So we can see that the maximum peak stress is a localized stress concentrated over a very small area. Let's check for step 2. So the location of the maximum stress remains unchanged. Same way we can check the total deformation. So we can see that the pile has a tendency to deflect maximum at the center. Let's check the weak spring forces. So on comparing the force reaction at the lift point and weak springs, we found that the reaction force at the lift point is significantly higher. So weak springs do not add any calculation error in this analysis. So we can extract this center of mass from the solution information. The objective is to ensure that the lift point is exactly at the center of the pile. So let's check the results. For load case 1, the allowable stress is 30,000 psi and the calculated stress is 17,800 psi. For load case 2, the calculated stress is below the allowable stress. With this, I will conclude this video. Thanks for watching.